harder pigeonhole questions. So for example, 29, every person has fewer than 500,000 hairs on their head. Well, yeah, probably. Prove that in Sydney, with a population of more than 5 million, there are at least 11 people with exactly the same number of hairs on their heads. Now, you're going to start off by thinking, well, maybe some people have 3 hairs on their head and some people have 11 hairs on their head, and maybe 100,000 people have 12 hairs on their head, but then that would leave a lot of rest, we always consider the averaged out case to start off with all of these questions. For any that are unbalanced, well, that automatically means that there's more than, for example, 11 people. Because if we've got less with this, that must be more with this. Does that make sense? So let's literally do this the nice, easy way. We know that 5 million divided by 500,000 equals 10, but Sydney's population has more than 5 million. So the population of Sydney divided by 500,000 hairs, is that enough zeros? Yes. Is going to be greater than 10. So some people, so don't forget we always round up with these. This is such an awkward way to write it. So 11 or more, at least 11, sorry, I should have written. Same number of hairs on their heads. Let's look at the next question. Vikram has 30 ties. They're different, distinct ties. Every day, including weekends. Fancy. He selects a tie at random to wear. How many successive dates are needed to guarantee that there is at least one day of the week on which he has worn the same tie on at least 6 occasions? So if we're wearing each of these 30 ties 6 times, that comes out as 180 days. If we do more than 180 days, he must have repeated one of the ties, at least one of the ties, more than 6 times. He could have worn one of them 0 times, but that would have to, he would have had to make up those extra days because he wears a tie every day with a different tie, and then one would have been more than 6 occasions. So 181 days. So if he wears his ties for 181 days, then at least one of those ties must have been repeated. Oh, at least 6. Did not read this question. So instead of timesing it by 6, 150. On the 151st day, he must have repeated one of the ties at least 6 times. More advanced examples, 15 people in a room, there are handshakes as they meet, no pair shakes hands twice. Proof there's at least 2 people who have made the same number of handshakes. So if I literally draw this out, person, 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 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so this person shakes hands with this one and this one. And this one shakes hands with this one and this one, this one, this one and this one. Doesn't really matter, etc. Then all up, we have Then each person is going to end up, oh, I totally misinterpreted this question. Ignore everything I've just spoken about. 15 people come into a room and there's many handshakes as they meet, but no pair shakes hands twice. So each person shakes hands between 0 and 14 times. So you're not going to shake hands with yourself, which would have been the 15th time. If someone shakes hands no times, then no one shakes hands 14 times. Like if I don't shake hands with anyone, then no one's shook hands with me. Shakes 0 hands, then no one else so can get to 14 because they can't have shaken hands with literally everyone else in the room because one person's being very sensible about coronavirus and not shaking hands. So 0 to 13 times shakes for each person. But we've got 15 people. So if we've got the options 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and we've got 15 people doing this, then we can't have had everyone shaking hands a different number of times because one person's 0, one person's 1, one person's 2, one person's 3, one person's 4, one person's 5, one person's 6, etc. You're going to end up doubling up because we've got 1, 2, 3, 4. We've got 14 options here, so at least one person, like we've got the 15th person, has to come in and double up the number of handshakes they've had. One person must have the same number of handshakes as someone else. If no one shakes their hands 0 times though, so everyone participates, then we've got people who must have shaken them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 times. We've still only got 14 options, so one person must double up. 14 options, 15 people, one person must double up. Okay, prove that there will be, yep. How many odd numbers less than 20 must be chosen to guarantee that 2 of the chosen numbers add to 20? Okay, I'm going to start listing the odd numbers less than 20. So if I've got 1, then for it to add to 20, it must go with 19. I could have 3, 17, 5, 15, 7, 13, 9, 11. So this is 1, 2, 3, 4, 5. So I think if I choose 6, if I choose 6 numbers, then I could have chosen 1, 3, 5, 7, 9 as the first 5 of them. None of those add up to 20, but then the only options I have left mean that one of them must then add up. So if I've got 1, 3, 5, 7, 9, then maybe I've chosen 15 as my next one, and that adds up. Or maybe I choose 1 in 19 straight away, so that was fine. But if I haven't chosen them in the first 5 numbers, then the 6th number must have meant that I end up adding to 20 with some of them. 20, not 2.